Hi there, in this video I'm going to connect the VFD and the spindle to Olivier's little CNC router engraver, so it should be quite interesting, fingers crossed. So I got this VFD off Vevor, and it's a model A2-8022, and the input voltage can be either 3-phase or single phase, and I struggled a bit trying to work out where neutral and live was. I'm not sure whether it matters actually, to be honest, but I put some sort of spade clips on here and some heat shrink, and I've put the brown wire, the live wire, to the R, neutral to T, and earth to the earth. So to connect the spindle to the VFD, I've got this shielded wire, 1.5mm squared, and it's 4-core, and I don't think I've followed the correct wiring convention here, but I've connected pin 1 to brown, which I think is the correct wiring convention. I've connected pin 2 to grey, which I don't think is quite right, and I've connected pin 3 to black. I think to get it properly right, grey should be reversed with a black, but it doesn't really matter because as long as I get it right on the other end. And I think pin 1 is U, pin 2 is V, and pin 3 is W, and I've connected a ground as well. Now the connector came with some heat shrink, so I've put some heat shrink on the sort of live connections. I've left the earth alone. And inside this cap here there is sort of like a piece of plastic on the inside to help avoid shorting. Now on the braided outside, this shielding, I've not connected to the earth, but this shielding I will connect to the earth on the other side, on the VFD. So fingers crossed I've got it right. So I've crimped some fork connectors onto the end of the wires and also soldered them, and I put a bit of heat shrink on as well. And for the earth, I've connected the earth to the outside sort of braided cable as well, and connected that to the earth contact. And pin 1 on here goes to U, and pin 2 on here goes to V, so that's the grey wire on my setup, and pin 3 goes to W, which is the black wire on my setup. And I've put a continuity tester on just to make sure that they're all in the correct sort of positions, and everything looks good so far. So this is the manual for the VFD, and I've spent ages reading this. There are loads of parameters that you can change, with detailed descriptions of what each of those parameters means. Now, I studied this for days, trying to work out what these defaults meant, because there's a default bracket 3 and a default bracket 6. I just couldn't work it out what that meant, and then it dawned on me that the 3 and the 6 refers to a setting of parameter 32. So if you set it to 3, it sets all the parameters to, well, it initializes them for the 400 Hz parameters for 400 Hz spindles. If you set it to 6, it will set the defaults for the 50 Hz parameters. So what you do is you go in and you set pin 32 to be 3, So it initialises all these parameters to these values, and then you set it to 1, which gives you the ability to modify each of these parameters. I won't go into the details about how you can modify them. I mean, it tells you here how you do it. It's all straightforward stuff. And initially I was going to change some of these values, but I changed them, and I got some errors coming up. So effectively I've just left them as defaults for the 400 Hz. And I think for the test these parameters should be okay. And I think when I need to drive it with the OpenBuilds black box, I think I'll need to change this source of runtime command to be equal to 2, so that's PN04. So to get an external signal. I think that's all I need to do. So like I say, for this test, without the controller set up and connected, I've just left these defaults, and we can see if we can run the spindle. So I've made this bit of a panel to hold all the mains electrics, and I've used these NVR switches, KJD12s, for emergency stops. I've just 3D printed these. My design isn't great, so I've had to cut a piece out of them. So for the spindle, obviously that's the incoming mains, goes into the NVR, comes out into those connections I showed you previously, and the output again is with those connections set as previously, and to the spindle. And what I've done is I've on the plug, on the mains plug, I've put a continuity tester on the earth to make sure I'm getting an earth from here into the body, which I am, and I'm not getting anything, any connections any other ways, which is obviously quite good and encouraging. So we'll give it a try. Now this, I think the way it's set is it'll go up to 400 Hz when it starts. So nothing at the moment, and if we run it, there we go, that's the spindle turning. That seems to work without any control from the black box. So what I'll do now is I'll wire the black box mains into this NVR and try and attach the black box up to this and see if we can control it with some Goebel commands. Now this is a bit difficult to see, but on the tool head connector I've connected the black wire to ground and the red wire to the 0 to 10 volts variable. Okay, and on the other end I've connected the red to the 10 volt in on the VFD and the black to ground. And now what I need to do is to configure the VFD so it's recognising the signal coming from these wires to control the speed. And having looked at it, there are two settings. There's a PN03. If you set that to 4, it looks for the external 0 to 10 volt signal, which is, I think that's what I need. But there's a pin 5 and it says the source of runtime command. So you can either go for panel button or external signal control. So I'm going to leave that at the panel button. So all I'm going to do is to change PN03 to a value of 4 and then we'll see whether it works. So set and go up, looking for 3, set, we need to set that to a value of 4. So at the moment it's set to 2, which is panel button. So if we set it to 4, it'll be the 0 to 10 volts. So 03, set it to 4, set. So this seems to be working reasonably well. I've sent an M3 S800 to the controller and that's set the speed to 310 Hertz. Now in theory, if I set it to 1000, it should go up to 400 Hertz. But I think there's a slight calibration problem here. I think there's some calibration needs to be done on the controller. So if I send that, the speed increases now. .388 Hertz. So not looking too bad so far. That's an M3S0. Now I've disconnected the wires going to the VFD and I've just sent this command here, M3 space S1000, so that actually should be sending 10 volts down the wires. And just put this voltmeter on and it's measuring 9.31. Now there's a potentiometer on the controller, so I just need to twiddle with that and get that up to 10 volts and then job should be a good one. Okay, so I've just made that adjustment with the potentiometer and it's sort of changing between sort of 10 volts and 9.99 volts, but I think that should be good enough. So I'll connect it back up to the VFD and hopefully this time we should get 400 Hertz shown on the display. Okay, so I'll try again. So I'll send it this M3 S1000. Hopefully it'll ramp up to 400 Hertz. one's going. Hey, that looks good. So if I send it an M3 space S800, that should bring it to, let me see, so it's 400 divided by 1000 multiplied by 800, that's about 320. Okay, 333, fairly close. And 0. Now it's just occurred to me that maybe I ought to change this $30 parameter in the default settings, the maximum spindle speed. It's currently set to 1000. So if I change that to 2400, or 24,000 rather, then and save that. Now when I type in the M3 $speed command, I should be able to put in the proper speed, and it should calculate the correct hertz value. So the instructions suggest that the minimum speed for this spindle should be 20,000, otherwise you have cooling problems. It does get quite hot though. So if I type this in, I should get, I think, around about 333 hertz shown on the VFD. Give it a try. Oops. So M3 S 2-1-2-3. And that's set the VFD nearly at 333. It's 348. So I can run it from here. All being well. There goes the spindle. So that's got up to about 20,000. And if I set it to its maximum, 24,000, it should go up to 400. So now I'm just running it in at 20,000 RPM. I'll do this for about 15 minutes. Okay, so that's 15 minutes. Pretty cool actually. Happy with that. My brackets aren't melting. Now the only thing I haven't managed to work out yet is I need to hit the run button on here to enable it to run and accept commands, speed commands from the controller. But I guess there must be a way of getting the controller to actually get it to run and stop between speed settings, but that's something I need to work on. Well, that was pretty exciting, but I must say I'm not an electrician by any stretch of the imagination, and messing around with 240 volts and that type of stuff is quite dangerous. So what I would suggest is don't follow what I do, get an electrician in to do the work for you. But there's a bit of useful information in there in terms of how to connect the controller up to that particular model of VFD, and also some of those VFD settings. So I hope some of you found that of use. And in my next video I'm going to be assembling the table. Now Olivier told me to buy this stuff. I think they call it 20 by 40 extruded aluminium. So I've just got 4 pieces of that. I just need to connect it up and attach it to the actual machine, but I can do all that bit off camera. And in my next video, hopefully, I'll be making something with this little CNC router engraver. So I hope you enjoyed the video, and I hope to see you later.